This is the lecture video that goes with your topic 9.5, assignment number 22. So in previous lessons, we were always working with simplifying radicals that were positive numbers. We learned in our first video of this unit that if we said you're taking the square root of -16, for instance, we would say that that was not a real number, because there's no way, like the square root of 16 would be 4, right? If we were thinking about a positive square root number underneath the radical. But there's no way for me to say 4 times 4 equals that -16 underneath, or -4 times -4 equals a -16, because that would make it positive, right? So anytime you had an even index, you were told to say it's not a real number. Well, now we're going to learn about imaginary numbers. So the number I is called an imaginary number. It represents like the square root of -1. So you can use I to rewrite negative roots or negative square roots underneath here. It's okay to have a negative in front of a radical, just not underneath of like a square root. And so they break it down a little bit differently in this printout than I do. You know, they pull that negative away, calling it a -1. And then really, I generally say pull the I out in front of that, because it looks like the I's underneath, which it's not. It's just kind of to the right of the radical. And so now we're really saying, what's I square roots of 4? And so the square root of 4 is 2. So we're going to call that 2I. So to make it a positive, to even be able to work at it or work with it, we pull an I out in front, and it makes it a positive. So that's all you're really doing in the first step. And then you treat it just like you have all the other simplifying radicals. So the square root of 121 is 11. So we'd say 11I. Here, that was a perfect square when we pulled it out. This 48 is not. So we'll still pull out an I so that we can even work with it, because the way it is right now, it's not a real number. You can't work with it. When you pull an I out of that, making it a positive number underneath that, for some reason, you know, you can magically work with it. So what we want to do is say, let our calculator say, well, what is the square root? And remember, it's a square root, so it's not a different index. So you can just use that button right there. Let me turn that on so you can see a little bit more. It's a little dark. And then type in 48. And so remember, that would simplify it to say, I'll write it down for just a minute. Like this right here would just be like saying 4 square roots of 3. But we pulled an I out. So you're going to say 4I square roots of 3. So you're going to put the I right beside the whole number part that you pull out. So your calculator will not do imaginary numbers for you. It's going to say that there's a domain error. So you have to know to be able to pull the negative out yourself so that you can work with it. Again, so we're saying I square root of 150, and then we take the square root of 150, and it's 5 square roots of 6. So since this, again, is 5 square roots of 6, because we pulled an I out in front of it, it's going to be put right beside the number 5. Kind of like a variable, except it's not a variable. It's representing that it is an imaginary number. So we're going to kind of talk about what a complex number is. A complex number is just when you have a real part and an imaginary part. So they're not like terms. If you want to think about variables, kind of think of the I a little bit like it's a variable, but not. You have a real part and an imaginary part, and that makes a complex number. And so when we do that, we always write the real part. So they're just saying A is the real part. And this term right here, BI, is the imaginary part. So we want to write the real term before the imaginary term for it to be in proper form when you write it. So the square root of 25 is 5. So we're just simplifying that. And this would be like saying I square roots of 64. Since it's a perfect square root, you may already just recognize, well, this would be represented as 8I. The square root of 64 is 8, and we have an I beside it. So this is my real part and my imaginary part. They're not like terms. One's real, one's fake, right? Real, imaginary. So they're two separate things. And that's all you can do with that. Example 58 is an example where maybe they're not perfect square roots. So again, you would use your calculator and say, well, what is the simplified version of 98? It is 7 square roots of 2. There's a minus sign in between the terms, so I'm going to pull that out. And this is kind of like saying I square root of 60. So I'll rewrite it, and then we will simplify the square root of 60. It's not always necessary. Once you practice doing this, I think you're going to know I'm pulling an I out. And when I find the square root of 60, I know it's 2 square roots of 15. So to show that that's imaginary, I have to say 2i square roots of 15. And so that is your answer. So this is the real part. You know, it is a radical, but it doesn't have an I with it, making it imaginary. And this is the imaginary part. Turning the page, we'll be working with operations that have to do with complex numbers. One thing that we're going to learn is that in this first part, if you're adding and subtracting complex numbers, you're really just treating it like kind of like a variable, like a polynomial. You're just combining like terms. If there's a plus sign in between, then you're really just saying 10 minus 2 if you rewrite it, and negative 7i plus 5i. I just ignored the parentheses and collected like terms beside each other to kind of rearrange it. So 10 minus 2 is 8, negative 7 plus 5 is a negative 2i. Is this necessary? Not entirely, but you do want to stay organized and make sure you don't forget that you're just combining like terms. It had a plus sign in between them. So you're just combining like terms, and like terms are the real parts and the imaginary parts. Right here, I have a minus sign in between. So remember with polynomials, it is necessary to change the signs to the right. So this would be a negative 6, and that's now a positive 8i. So I'm taking a negative 2 and a negative 6, which make a negative 8, and a negative 4i and a positive 8i, which is a positive 4i. So if you don't rewrite it, it's okay. I will go ahead and rewrite it just to kind of show you. I didn't change, I changed the signs because I had to distribute the negative. But then if you rewrite it to collect like terms, you're just showing it like that. But sometimes you may need to simplify your radicals before you start to try to combine like terms. So like this would be like saying I square roots of 64. So in this is really like saying 6 minus, because there's a minus sign out in front of that term. And if I say the square root of 64 is 8, so I have an 8i, and you can put it back in a parentheses. So you need to simplify radicals. And then we have a minus sign again. And in that parentheses, I have a negative 15 and a plus sign. But again, this would be like saying I square root, so 144. Since 144 is a perfect square, that'd be like saying 12i. And then we treat it just like we did in example 60. We have a minus sign, so you have to remember to go change the signs. Then you can just combine like terms. So this is like saying 6 plus 15 minus 8i, and that we changed it to minus, so minus 12i. And so 6 and 15 make 21, negative and negative make a negative, 8 and 12 make 20i. And so remember, again, I'm specifically putting the real part before the imaginary part to keep it in proper order. So we have to simplify these radicals first too. This one's okay to simplify. You can just ask your calculator. Since it's a positive square root of 8, that would be 2 square roots of 2. But here, remember, it's like you pull an I out, then you can type in the square root of 18 into your calculator. So since there was a plus sign, I just brought that down, and I'm going to say, well, what is the square root of 18? It's 3, but 3i square roots of 2. And then I have a plus sign in between, so I'm not going to have to change signs to this parentheses, so that'll be nice. I can enter that into my calculator and say, well, what is the square root of 32 simplified? It's 4 square roots of 2. And then you have a minus sign. And again, this would be like saying I square root of 72. So what is the simplified version of square root of 72? It's 6 square roots of 2. So since it's imaginary, we say 6I square root of 2. Then we can collect like terms because these are real parts, and also because they have the square root of 2 beside them, we could write them side by side to show that they will be combined here in just a second. And then I have the imaginary part. So that's plus 3I square roots of 2 minus 6I square roots of 2. And so I'll be combining those parts. So there's a couple things that make them like parts. Number one, these are real terms, but also they have radicals that are exactly the same. So 2 plus 4 is 6 square root of 2. And these are imaginary parts that make them like terms, but they also have the same radical. So yes, we can combine them. So 3 minus 6 is a negative 3I square root of 2. So that is our solution, our answer, simplified version of number 62. Looking here at multiplying complex numbers, we do learn that when we simplify some of these, you may be multiplying an I times an I. So it's pretty much very similar to when we're multiplying polynomials. But the thing is we are learning that if you see an I squared, you will always replace it with a -1. It's a constant value and a rule that you just memorize and do. And then again, we write our final answer in the correct form of real part plus or minus imaginary part. So again, what you get from the notes up there is anytime you see I squared, you replace it with a -1. Just like anytime you saw negative under radical, you had to pull an I out first. Okay, so that was just kind of a rule to make it a positive. So here, if we multiply -6 times -4, that gives me a positive 24, and I times I would make I squared. So this is where if you see an I squared, we replace it. It's like a given value with a -1. So if it's right beside the 24, that already indicates multiplication. So 24 times -1 is a -24. And then again, kind of going back to the first of the video, I can't take -2 times -8. Because right now, both of those radicals are considered not a real number. You can't do any operation with them until you pull an I out. So I square root of 2 times I square root of 8. You must do this first. If you took -2 times -8, you would get a positive 16, right? So it's going to make it a way different answer than if we remember, I can't even multiply them because right now, these aren't real numbers. I turn them into imaginary numbers, so then I can do operations with them. So we can multiply the front parts together, which makes that an I squared. Now we can multiply the underneath together. 2 times 8 is 16. So simplifying both of those things, this would be like saying a -1 times the square root of 16 is 4. Okay, so your calculator's not going to do the I's for you. You have to be able to work with that and remember those rules. So -1 times -4 or times 4 is a -4. Again, it's very much like working with polynomials. For this example, you're just distributing. 3i times 3 is 9i. 3i times a -7 is a -21i squared. So if we have an I squared, we're not quite done here. We can say 9i, I can't change I. This would be like saying a -21 times a -1. Remember to kind of pick that sign up with it that's in front of it. So that makes it a positive 21. So if you're multiplying something times an I squared, basically it's changing that sign, right? Because you're multiplying it times a negative. But to write it in proper form, my real part ended up at the end then. So I would say 21, and since that's a positive 9i plus 9i, if you write it in the proper notation. Again, we can't jump straight into multiplying like we might want to. We need to pull the i's out first and then do our multiplication. So this would be like saying I square root of 3 times, you could just write the square root of 27 minus I So we had to fix those two things, and there was a minus sign in between them, and we pull an I out, and that makes it a positive. And so then you could just multiply if you want. I'm going to say I have an I, and in my calculator, you can tell your calculator to do the multiplication, and it would simplify it in the same step. So if I said, what is the square root of 3 times the square root of 27, and click enter, and that would have been like 81, the square root of 81, which when you simplify it becomes a 9. So I'm gonna write that it would have been 81 so that you can see the square root of 81 was 9, so that became a 9i. So it just depends on how you're working with your calculator, how you do this. Minus I times I makes I squared, and 6 times 3 is 18. But again, we want to change this. So there is a negative there, but this would be like saying -1 times whatever the simplified version of the square root of 18 is, which is 3 square roots of 2. So that looks really weird and funky because what's happening all over here is some stuff that we're going to have to simplify. So 9i, this really is just saying a negative times a negative is a positive. And then I have 3 square roots of 2. And then again, we have to rearrange it to put it in the right form. So 3 square roots of 2 plus 9i. I'm personally not in the habit of relying on my calculator to do everything. So that's why I go ahead and write that step. Notice in your calculator, when you did it, it took you straight to 9. You just have to remember that you had a 9 out in front if you do that. And we pull an I out in front. I think writing the step that I'm starring is very helpful for you. And like this, you know, I wrote 2 times 8 is 16, but if you did that in your calculator, it would have told you that it would have taken you here. So you would have thought maybe I squared times 4. It's just your habit of order of using your calculator. Okay, 5 times 8, we're going to have to FOIL this because this is kind of like a binomial times a binomial. 5 times 8 is 40. 5 times a -4i is a -20i. -2i times 8 is a -16i. -2i times -4i is a positive 8i squared. So we have some terms we can combine, and we have an I squared that we can simplify. So we can combine this. So 40, -20, and -16 make a -36i. And this would be like saying 8 times -1. I'm just going to put a line through it and say that would be like -8, right? Because I see that way I didn't have to rewrite it all, but you could. But I'm going to have to combine those real parts. 40 minus 8 is 32. So you're combining like terms, and then write minus 36i. So it's bringing some of those same rules into that you were doing with polynomials. I know sometimes I will say 8 times -1 here, and then just that way I can see that instead of writing it in this next spot and then just saying, well, 8 times -1 was -8, and then I need to combine those real parts. Again, before we jump straight into distributing, especially when we see those radicals, because we have negatives underneath the radicals in these two terms, that means I need to pull an I out first. So this is the square root of 5 minus I square root of 2 times the square root of 5 plus I square roots of 2. So hopefully you may recognize from the previous lecture video that these have same first terms and second terms with opposite signs. What is that called? That's called a conjugate. Meaning you could go through your entire FOIL process if you want, but your inner and your outer terms will always cancel. So hopefully you recognize that pattern and you think, well, I could just take first times first, which would give me the square root of 25. And I could take last times last. So positive times a negative or negative times a positive makes that a negative. I times I makes that an I squared, and 2 times 2 makes that a square root of 4. So I didn't rely on my calculator to do any of that for you. If you are, then you need to practice that and just make sure you get the same answer as I get, working with your I's. So the square root of 25 is 5. So this would be like saying you have a minus, and I squared becomes a negative 1. So that's going to change that sign right there. It's what you're going to notice when you have an I squared by something. And the square root of 4 is 2. So that does look kind of busy because it's like we have all of this going on that could simplify now, right? It's saying if you could write it as 2 separate steps, I suppose. You could say 5 minus if you're not paying attention to that. And negative 1 times negative 2 is a negative 2. But what happens there? That's a double negative. Instead of doing that, I would have thought negative times a negative makes that a positive 1 times 2 is a positive 2. And then we just get down to the simple number 7. So just like with the radical terms, whenever we had to rationalize denominator, you can't have a radical in the denominator, but you also can't have an imaginary number in a denominator. So they're very similar rules that are kind of rolling over. And so when we multiply conjugates together, it's going to get rid of radicals and i's. And so the last rules that you learn with the operations of imaginary numbers, working with those complex numbers, is kind of that same thing with division or when you see a fraction line. The only thing is, if you see an I in the denominator, I don't necessarily have to multiply times the 7 and the I if there's only one term. I'm just trying to remove the I. And so if I just multiply times I when there's a monomial down there, again, it doesn't matter the coefficient in front of it, we will be getting rid of it. If you multiplied with the 7, you're just going to have to reduce it by 7 in the end. And I'll show you that. So at the top, 3 times I is 3I, and 7I times I would be 7I squared. So remember, we're replacing that denominator with that I in the denominator with a negative 1. So that would be like saying 3I over negative 7. You know, you could put the negative just out to the side. It doesn't really matter. Seeing a negative in a fraction makes it just a negative. Doesn't matter if it's on the top, bottom, or out to the side. If you would have multiplied that times there wasn't an I there. If you would have said, I'm going to write it on the back. If I would have said, I'm just multiplying times 7I, you're creating yourself extra work when there's just one term down there. 3 times 7 is 21I. 7 times 7 is 49I squared. So you would be changing that to like a negative 1, which makes it a negative 49. And then you'd have to go back down and reduce. They're both divided by 7 because you multiplied it by 7. So that would go back down to 3I over 7. Okay, so it's not like I just pulled the I up front, even though, and it's negative, sorry. It's not like I just pulled the I up front. It's because I just multiplied by I. That's all you need to do when it's one single term. One single term, just multiply times I. With radicals, you know, you multiply times the exact same radical. I'm aware of that. Like if it was the square root of 2. With this, you just multiply times the letter I to get rid of the letter I. So here we're going to do the same thing. There's only one single term down here, just a negative 5I. So if I multiply times I, I'll be getting rid of that denominator. But because there's more than one term here, we will have to distribute. So 2 times I is 2I minus 3I times I is 3I squared over negative 5, and I times is I squared. So we have a couple things that happen. I'm going to write it above because I'm kind of running out of space. So this would be like saying 2I minus 3 times negative 1. So that would be like saying 2I plus 3. So again, this I squared just changes it to positive. This would be like saying negative 5 times negative 1 is a positive 5. The only thing wrong at this point is that the top part doesn't have the imaginary or the real part, then the imaginary. So let's rewrite it. Say 3 plus 2I over 5. Now, example 71, we could not multiply just times I, kind of reverting back to when you did that with radicals and you had a binomial that had a radical, you multiplied times its conjugate, okay? So here we're multiplying times 3 minus I. So in the top, you are distributing. 3 times 9 is 27, and 9 times a negative I is a negative 9I. And then down here, because they're conjugates, to save yourself time, remember you could just multiply times your first and last. If you do FOIL in its entirety, that's okay. Your middle term will just cancel out. So 3 times 3 is 9. I times a negative I is a negative I squared. So we're good here at the top for a moment. So we can just write 27, 9i, there's nothing to do there. But here, this is like saying 9 minus a negative 1, because this becomes a negative 1. So hopefully you recognize that that became a double negative. So that would be like saying 9 plus 1 is 10. If in your denominator, I didn't talk about it on this number 70, if you see that they could maybe reduce, you would be able to pull it apart and write each term over 5 separately. But since separating them didn't make it where I could reduce either of them, it's okay to write it as just all over 5. Same here, I could pull 27 over 10 minus 10i over, or 9i over 10, but again, I couldn't reduce it, so it is okay to just leave it like this.